Hello students, in this lecture we will see one more numerical on nodal analysis. So the problem statement is find the voltage drop across 100 ohm resistor using nodal analysis. So the first step is identification of node. So you can find out one node over here. I will assign the voltage at this point as Vx. The second node is over here. I can assign the voltage as Vy, and the third node at this location the voltage is Vz. One more node is there and that I will treat as a reference node. They are saying find the voltage drop across 100 ohm resistor. 100 ohm resistor is over here. So if you calculate the voltage Z, Vz at node Z, you can easily calculate the voltage at across this 100 ohm resistor. Now there are three unknowns and I want three equations. If you try to apply KCL at node X, what will happen? You can easily write down this current, and even this current I can write down. But when you try to apply KCL, that is current, and we are able to, when you are writing the current through this one, there is no resistance along with in series with this 60 volt source. So you can't write down current flowing through this branch. So you can write from node X, Vx is equal to 60 volt. This is the situation where exclusive voltage source. What do you mean by exclusive voltage source? Only a voltage source, not even a single resistor in series with this one, is connected between the node and the reference node. Then we will get that voltage at the node directly. So Vx is equal to 60 volt. One can write down this in equation format as 1 Vx plus 0 Vy plus 0 Vz is equal to 60. And this is my equation number 1. The second equation will obtain by applying KCL at node Y. Summation of outgoing current at node Y is equal to summation of incoming current at node Y. 1, 2, 3 and 4. 4 branches are connected to node Y. And out of that 4 branches, in one of the branch there is a current source that is 0.6 ampere and it is moving towards Y. So this is the incoming current. So I will write on right hand side. So 0.6 ampere is the current over here. Now I have to account the remaining 3 currents flowing through these 3 resistances. So the leftward current I can write down Vy minus Vx by 20. The rightward current one can write down as Vy minus Vz by 20. And the current over here, which is a downward current through this one, can be written as Vy minus 0 because we have reached at the reference node and the resistance is 20. This 20 ohm is connected between node Y and the ground node. Similarly, this 0.6 ampere is between the reference node and the node Y. So LCM over is 20. So I will multiply throughout by 20. I will get Vy minus Vx plus Vy minus Vz plus Vy is equal to 20 into 0.6, and that will give me answer as 12. So in equation format, this is minus Vx plus 3 Vy minus 1 Vz is equal to 12. And this is equation number 2. Now I have to write down the third equation. So KCL at node Z. Can you apply KCL at node Z? There is no problem over here. No problem for this branch also. Even no problem for this current, and even one can write down this thing. So when you are applying KCL at node Z, you have to write a summation of outgoing current at node Z is equal to summation at incoming current to node. So no current source is connected to node Z. So I will assume all the currents as outgoing, and there are 4 outgoing currents. So this current can be written as Vz minus Vx divided by 50. This leftward current can be written as Vz minus Vy by 20. The downward current is written as Vz minus 12, and then you reach at reference node, so minus 0. And the resistance in this path is 20 ohm, so that will go in the denominator. And current through this 100 ohm, this resistance they have mentioned as 50 ohm. 20 ohm is for this resistance, so this is 50 ohm. So I will make correction over here. This is 50 ohm. And current through this resistance is Vz by 100, and this is equal to 0, no incurrent. So LCM over here is 100. So one can write down multiplying by 100. You will get 2 Vz minus 2 Vx plus 5 Vz minus 5 Vy plus 2 Vz minus 24 plus Vz is equal to 0. So in equation format, this will turn out to be minus 2 Vx minus 5 Vy and then you will have 2 plus 5 7 plus 2 9 plus 1 10 Vz. 10 Vz is equal to 24, and this is my equation number 3. So there are 3 equations and you have 3 unknowns. So that is the fair thing in mathematics, and one can substitute these coefficients and constants in the calculator and they can calculate Vx, Vy and Vz. So Vx turns out to be 60 volt, while Vy turns out to be 34.56 volt and Vz turns out to be 31.68 volt. The problem is not over. They are saying find the voltage drop across 100 ohm. Now 100 ohm is connected between the node and the reference node over here. So voltage can be written as voltage across 100 ohm can be written as voltage across node Z or node voltage at node Z. So that turns out to be 31.68 volt. Thank you.